66 million years ago, an asteroid as big as Mount Everest was headed on a deadly collision course with Earth. The impact was so devastating that it wiped out the most gigantic, deadliest reptiles to ever roam our planet. But the dinosaurs didn't just die from one big boom. No, they faced a slow, agonizing end. How did this extinction event cause the largest tsunami Earth has ever seen? And what exactly happened after the big reptiles were gone? Hold on tight, we're taking you on the most epic and deadly trip of your life. This dinosaur-ending asteroid is terrifying. Not only was it about 10 kilometers in diameter, but it also traveled incredibly fast, between 10 and 30 kilometers per second. At this point, it was a blazing fireball. As it hurtled down to Earth, the air in front of it was compressing and heating up to unimaginably hot temperatures. Just before the impact, the asteroid could have been as hot as the surface of the sun. Once it entered our atmosphere, it only took this massive space rock a few seconds to reach Earth's surface and alter the course of life forever. As the asteroid slammed into Earth off the coast of where Mexico is now, it sent huge amounts of debris up into the air. The shocking blast wave killed everything in its way, and from here, it was only getting worse. This powerful blast ejected bits of the Earth's surface into the atmosphere, and minutes later, scorching hot pieces of glass and rock rained back down. Some of the debris reacted with the atmosphere, causing acid rain that would last for years. The land was burning. The fires caused by this devastating impact spread across the continent like literal wildfire, killing more and more life along the way. And then, just when you thought the apocalyptic scenario couldn't get any more intense, well, it did. The impact of the asteroid hitting Earth was so powerful that it sent shockwaves through the planet. And all that energy had to go somewhere. Cue the mega tsunami. A wall of water over 10 meters high raced across the ocean. This wasn't your regular tsunami. It was a staggering 30,000 times more powerful than anything you see today. As this monstrous wave spread across the North Atlantic and South Pacific, coastlines didn't stand a chance. The wave hit with such force that it destroyed and reshaped the continent. If you were there to witness this apocalyptic destruction, well, you wouldn't survive any of it. But some dinosaurs did. Yeah, the ones further away from Ground Zero weren't immediately obliterated by the impact. They weren't incinerated by the resulting infernos, and they managed to avoid being swept away by the mega tsunami. But still, their fate was sealed. As the dust began to settle, it was the start of a nuclear winter. Even though it wasn't nuclear weapons that caused it, the effect was the same. The massive amount of debris in the air blocked the sunlight for months, maybe even years. Earth suddenly became a cold, dark place, and the dinos weren't ready for it. As temperatures plummeted and fires released enormous amounts of greenhouse gases, the climate changed dramatically. Plants weren't able to perform photosynthesis, and most of them started to die out. This disrupted the food chain and starved many of the animals that survived the impact. And remember the acid rain? It lasted for several years, causing more devastation to the ecosystems. The oceans became too acidic for marine life. Most ocean species didn't have the time to adapt to such a drastic change. These prolonged harsh conditions, together with the initial blast, pushed about 75% of Earth's life to extinction. The good news is that this included the horrifying T-Rex. Yeah, as much as I feel bad for this guy, I'm happy he's not running around today. When the last of the dinosaurs breathed their last breath, Earth became an empty, devastated place, cold and acidic. So when did things get back to normal? Yeah, well, here's the thing. They didn't. Not dinosaur era normal, anyway. Earth didn't rebuild after that. It reinvented itself. 1,000 years later, the planet was recovering from the post-apocalyptic winter. It was still cold and food was still scarce, but life was ready to make a comeback. In this new wild world, a few furry little critters were sprinting around. Among the first plants to reappear after the impact were ferns. They really hit it off well after the disaster. 100,000 years later, Earth began to get a little more lively. Creatures about the size of raccoons were repopulating the continents. And the oceans were once again teeming with life. Fast forward about 10 million years and Earth had finally restored its biodiversity. Only it wasn't the same Earth as it used to be. Now it was the age of mammals. Yeah, after the dinosaurs checked out, mammals were on fire. Yeah, not literally, of course. Mammals, together with birds and flowering plants, were rocking the planet. Yeah, Earth never got back to its old self. After the last dinosaur died, it took our planet millions of years to bounce back in a new way. But don't get me wrong, this world was still pretty terrifying. It had beasts like Paraceratherium roaming the land and megalodons raining terror in the oceans. Yeah, it's really for the best that most of these creatures aren't around these days. You wouldn't want to face a meg when you're out there swimming in the ocean. Earth has gone through at least 5 major ice ages in its history. And you better start adapting now, because another ice age is about to begin. Hypothetically. How would a new ice age change Earth as we know it? What could you do to survive on a frozen planet? And how are we already delaying another ice age? This is What If, and here's what would happen if we entered a new ice age. During all ice ages in Earth's history, global temperatures dropped well below freezing across the planet. And it wasn't just a few icy trips around the sun. Earth can take hundreds of millions of years to thaw out. The most recent ice age started the Quaternary period around 2.6 million years ago, and technically, we're still in it today. Ice ages have the power to radically change our planet. They reshape landscapes, they create new lakes and rivers, plants and animals cling to life, either adapting or facing extinction. So, if a new ice age began today, how soon would our civilization collapse into chilly chaos? Our 6th major ice age would be a few thousand years in the making, and it would begin with Earth's tilt on its axis going through its cycle of changes. An unstable tilt plus a little wobble in our orbit around the sun, and there would be less and less solar radiation reaching the planet. You'd see the first effects of this on the northern hemisphere. Each year, the once lovely summer temperatures would start to drop. Eventually, they'd fail to rise above freezing. And that's when the snowfall would begin to build up. Over time, that snow would compress into ice sheets. These glaciers would start in places like the northernmost regions of Canada, Scandinavia, and Russia, and they would spread from there. The ice would mostly form on dry land. That's because the water surrounding the ice would create a barrier preventing it from expanding as easily. Today, about 10% of Earth's land surface is covered by ice. As our new ice age progresses, you could see that go up to about 25%. Ice would cover Eurasia from the British Isles to Siberia. Himalayan ice sheets would expand through Asia, and while the southern hemisphere wouldn't be as icy, an ice sheet would run from the southern tip of Patagonia well into the Andes Mountains. But ice wouldn't be the only change. Sea levels could drop around 120 meters lower than they are right now. This could close off the Mediterranean Sea to the Atlantic Ocean. Without anywhere else to go, rainfall and glacial melting would feed bodies of water in regions that aren't frozen over. Some rivers would also change their usual runoffs and form new lakes. With all these changes in sea levels around the world, land bridges would re-emerge. Russia would now be connected to Alaska, and the islands of Indonesia would connect to mainland Southeast Asia. The borders would change and bring many countries closer together. Or it would result in whole new countries being formed, opening up new land for you to migrate to. And you'd need to. Regions that you and hundreds of millions of other people used to call home would be essentially uninhabitable. Surviving the cold would mean moving away from the iciest parts of North America and Eurasia. But the rest of the world wouldn't be too welcoming either. It would get really dry. Deserts and tundras would expand, so the remaining tropical forests near the equator would be refuge for much of the planet's plant and animal life. But what about us? Well, during the most recent ice age, we actually developed as a species. The land bridges allowed us to spread out across the globe, and the climate forced us to adapt with new tools and clothing. And as Earth rewarmed, we started farming. It's likely that we wouldn't fare as well with a new ice age. Not right away, at least. Almost all of our agricultural land would be lost. So intense overcrowding in hospitable regions would create chaos and unrest. You should get ready for extreme competition for life's basic necessities. But I do have good news to ease your worries about this frigid doomsday scenario.
Come on! Prove it!
Well, sort of. Based on current climate science and the amount of carbon dioxide in our atmosphere, we may have postponed the next possible ice age by about 500,000 years. And if we keep pumping out greenhouse gases, it's possible that we've not only postponed it, but we've made it impossible. That just means we'll all overheat, which I guess is better than being frozen. So, Earth freezing over may not need to be high on your worry list, but maybe all the world's ice melting should. Imagine you're out for a walk on a lovely day with not a care in the world. The birds are singing and the sun is shining. Actually, the sun seems brighter than usual. And come to think of it, your skin feels kind of funny. It turns out that's not the sun at all, but the radiation and gamma ray filled light coming from a quasar. So, in short, you're in serious trouble. How did a quasar even get here? And what would happen to Earth if a quasar moved into our neighborhood? This is What If, and here's what would happen if a quasar entered our solar system. I hope you didn't have any plans today, because the brightest object in the sky has set up shop in our solar system. So what exactly is going on anyway? A quasar is the result of two black holes colliding to form a supermassive black hole. with a central mass that outweighs our Sun by 1 billion times. When black holes merge, everything goes out of whack. The two black holes begin to consume all the gas and dust from each other, along with anything else in the area. Okay, so if they're eating each other, why are we seeing that bright light? Well, the material that's thrown off begins to glow from pressure and friction, resulting in the blinding light you're seeing. If this were to happen in Earth's vicinity, it would be a result of the black hole in the middle of the Milky Way galaxy smashing into the black hole at the middle of the Andromeda galaxy, which is 2.5 million light years away. If these two met, we'd be looking at a massive amount of infrared light being expelled into the universe. Oh, and it's also a harbinger of death and destruction, too. What would happen to our planet? Well, brace yourself because this is going to be a doozy. Quasars throw off jets of particles that are so bright they outshine all the stars in their galaxies. So our Sun would essentially turn into a candle in the middle of a very bright spotlight. The illumination from a quasar, along with all the radiation it throws off, would mess with Earth's atmosphere. The light is enough to energize particles that make up the atmosphere and free them from Earth's gravity. Our atmosphere would be destroyed, and we really need our atmosphere. It's our protective layer that keeps things in order and regulates the temperature. Without it, the oceans would dry up, Arctic ice would turn into water vapor, and everything would get much, much hotter. In addition to it being blindingly bright, we would have no safe air to breathe, no plants to eat or feed animals, and there would be no water to drink. Life on Earth would be a write-off. This would all happen very quickly, so you wouldn't have to live through a long, drawn-out apocalypse. At least you can look forward to that. But could this sort of doomsday scenario actually occur? Well, yes, but not for another 3 or 4 billion years. At that point, the Sun will be flickering out. And by that time, we're pretty sure something else we've covered on What If would have taken us out first, so we won't even be around to see it.
Oh my God! Oh Jesus! Oh my God! Oh my God!
Twinkle, twinkle, little star, how I wonder what you... What? Wait a minute. Why are you twinkling so much? Whoa, guys, that's no diamond in the sky. That looks like a supernova. As much as we love to blow stuff up here on Earth, no bombs or pyrotechnics could compare to the incredible force of nature's biggest explosion, the supernova. As a star reaches its grand finale and explodes, what would happen to life on Earth if we were close by? How far away from a supernova are we considered safe? Could anything survive its deadly radiation? And what makes supernovae valuable to us? This is What If, and here's what would happen if a supernova exploded close to Earth. Before you freak out, Earth is in a relatively safe patch of space called the local bubble. This peanut-shaped region of expanding gas in our Milky Way galaxy results from nearby supernovae explosions that occurred 20 million years ago. These explosions helped shape our solar system, spreading gas, dust, and heavier elements like uranium and gold to Earth. Without these supernovae, we wouldn't have any shiny gold bling or powerful nuclear reactors, so you can literally count your lucky stars. Okay, but are we in danger of any nearby supernovae? On average, a supernova will occur about once every 50 years in the Milky Way. Thankfully, there are no stars massive enough to become a supernova within 50 light years of the Earth. There is, however, one binary star system within 159 light years of Earth that could potentially put us at risk. Binary star systems are Type 1 supernovae. This happens in a tumultuous dance between two stars where matter is sucked from one star into another, typically a white dwarf. Eventually, the white dwarf explodes, resulting in an epic supernova. On the other hand, Type 2 supernovae occur when a star runs out of fuel and some of its mass flows into its core. Over time, the core will start to grow and get so heavy that it can't withstand its gravitational force, and then kablooey! The core collapses and a supernova is born. When these explosions occur, a powerful blast of radiation is spread throughout space that will kill anything within 50 light years. To put this in perspective, our solar system is only about 2 light years wide, so the supernova's blast would be the distance of 25 of our solar systems in a row. If a supernova occurred as close as 30 light years away, we'd have bigger problems than a pandemic on our hands. The intense blast of radiation would carry a massive influx of high-energy neutrinos that would boil any living creature from the inside out. Hope you like your meals poached. The entire Earth could be vaporized in just a fraction of a second if the supernova was close enough. The shockwave would arrive with enough force to wipe out our entire atmosphere and even our oceans. The exploded star would grow brighter for about 3 weeks after the explosion, casting shadows even during the day. Even if life survived, the superheated gas from the supernova would emit deadly amounts of UV and gamma radiation. These rays would destroy the ozone layer, leading to the formation of nitrous oxide smog. We would all have to go deep underground and embrace our new lives as mole people to escape the lethal radiation and poisonous atmosphere. Unfortunately, there would be an increase in mutations and deadly cancers. And to top it all off, our phytoplankton, which account for almost 50% of all photosynthetic activity on Earth, would die off. Phytoplankton is vital to us and can absorb carbon dioxide from our atmosphere. Without it, we'd have a tougher time breathing. Global warming would accelerate even further beyond our control. And as an essential food source at the bottom of the marine food chain, a lack of phytoplankton would result in sea creatures becoming extinct. And eventually, humankind would too. So, like many what-ifs, almost everything dies.
No! No!
But there might still be a few lucky species of extremophiles that could survive the intense radiation. After a few hundred or thousands of years, the supernova would leave an impressive nebula in its wake. At the very least, we'd have a fantastic view in our night sky. Well, for those of us that can see. Maybe these extremophiles would evolve to have eyes someday and become the size of humans.
They're massive and extremely dense. They rip apart anything and everything that gets close to them. We can't see black holes, but we know they have the destructive power to wipe everything out of existence. This is What If, and here's what would happen if a black hole deleted the universe. Before we get to the part where a black hole erases the universe, let's make something clear. The universe is a giant supercomputer processing information. Without information, there can be no universe. But what is information? In physics, information is the property of a specific state of a particle. I know, it sounds confusing. Here's a simpler way of looking at it. This is a carbon atom. A bunch of these can be arranged to make a hard diamond. But if you change the arrangement of atoms, you can get soft graphite. The basic building blocks are the same, it's information that makes them different. In quantum mechanics, information is like energy. It can't disappear into nothingness. So how, in the universe, can one black hole do the impossible? That's the black hole information paradox. Black holes act like monstrous cosmic trash compactors. They squeeze stars, planets, and unfortunate astronauts who cross the event horizon into a microscopic point. So, what happens to the information about every particle that a black hole consumes? Since information can never be destroyed, it has to be stored somewhere inside that black hole, right? Our original understanding of black holes assumed that everything that disappeared in the black hole stayed in the black hole. The moment an object passed the event horizon, it got crushed into the density of the black hole. The information about it could never be retrieved again. That's what we thought before Stephen Hawking introduced Hawking radiation. Hawking realized that black holes aren't static. Rather, they release their mass and energy back into the universe, particle by particle, until there's nothing left. So, does that mean the information within a black hole can somehow escape with the black hole's outgoing radiation? Not quite. The black hole doesn't preserve the information it consumes, it chaotically mixes it together with other bits of information, making it impossible to recover. The information is lost forever. If the information can be lost, that would mean that black holes can eventually delete the universe. Forever. But there is a possibility that the black hole doesn't delete the information. It may be hiding it in a baby universe, a small, self-contained part of the universe that branched off of ours. The information wouldn't technically be lost, but we wouldn't be able to interact with it. Another possibility is that black holes can encode the information, according to the holographic principle. If you were to get trapped inside a black hole, you'd still experience three-dimensional space. For us, looking at you from the outside, you'd appear stretched on the flat surface, just like a hologram. That would mean that the information paradox is resolved, and we don't need to rewrite the laws of physics. But we'd have to rethink our understanding of reality. The universe could be a three-dimensional image projected off a two-dimensional surface. And you may be a hologram on the surface of a black hole. And the best part? The black hole couldn't delete the universe after all.
So, we all know about the Big Bang, right? The cosmic explosion that created our universe? Well, as with everything, there is a beginning and an end. This is the Big Rip, the ultimate fate of our universe. It will be a cosmic event that will tear apart galaxies one by one. Stars, planets, you, everything will be eviscerated. Luckily, it's not going to happen for another 20 to 30 billion years. But what if we weren't so lucky? What if the Big Rip happened tomorrow? What would happen to our planet? And would this really be the end of everything we know? This is What If. And here's what would happen if the Big Rip happened tomorrow. In the future, the Big Rip will literally tear apart the universe. A process that will take about 1 billion years from start to finish. But the mad scientists here at What If have sped up the clock.
So that's, coming along.
The Big Rip is now scheduled for tomorrow. Try to get some sleep now, you've got a big day ahead of you. So, how will this go down exactly? Well, something called dark energy is driving the expansion of the universe. So, as the universe expands, so does the dark energy. During this expansion, dark energy transforms into something called phantom energy. And no, it's not just going through a goth phase. If this transformation happens and the phantom energy increases faster than the expansion of the universe, the Big Rip is set to make its debut. Think of it like a water balloon, and the water is filling the balloon up too fast, eventually the balloon will pop. But in this case, it's not a balloon, it's the entire universe. Meanwhile, back on Earth, you're going to have a very, very interesting day. Imagine that you're looking up at the beautiful night sky and you see a shooting star. Wait, that's not a shooting star, that's the Andromeda Galaxy. And it's moving away from us. That's weird. So, since you're confused about what's happening, you whip out your telescope and try to get a closer look. You try to look for other galaxies in the local group of galaxies, but they're gone. Suddenly, all the stars start moving away from you. It looks like you're traveling at light speed. That's the Milky Way breaking apart. You see Saturn shooting through the night sky, and oh my, there goes Jupiter, and oh gosh, you got Mars too. Then, all you see is blackness. The sky is empty of any stars. There's just complete darkness. Okay, it can't get any worse, can it? Well, now the ground is shaking and you see massive tidal waves, earthquakes, and volcanic eruptions. This is because the moon is breaking away from Earth's gravitational pull. But before you even have a chance to react, the Earth will be snatched away from the sun and it's going to get really, really cold. And for the grand finale, our planet will be torn apart and explode. Luckily, you'll be dead by the time this happens. Yeah, you heard me. I said luckily. If you manage to survive long enough during the explosion, you'd be able to witness your own disintegration. All of your molecules would be getting pulled apart. As you unraveled, all the atoms that make up your body would be swirling around, disintegrating into electrons and protons and neutrons. And then, poof, they'd rip apart as well, leaving nothing behind. Nothing is sacred to the Big Rip. And as the universe keeps expanding, it'll get ripped apart too. The universe is gone. Just gone. Or at least, it's gone as we know it. We have no idea what would occur after the Big Rip. That's totally unknown. So, sorry for the spoilers, but that's how we close the book on our universe. Thankfully, we'll all be long dead before the Big Rip happens. And that's because another cosmic event is going to kill us first.
Some 13.8 billion years ago, a very hot, small and dense singularity expanded into what we now call the universe. It hasn't stopped growing since, but what if it did? What if all the galaxies, stars, planets, everything stopped moving away from everything else? Would the universe as it is just freeze? Or would it collapse into a single point, just like it was before the Big Bang? And would that be the end of everything? This is What If, and here's what would happen if the universe stopped expanding. Before the 1920s, when Edwin Hubble observed that the galaxies moved away from each other, we thought the universe was static. Years later, the Hubble Space Telescope showed us that not only is the universe expanding, but it's growing at an ever-increasing rate. This came as a total surprise for astrophysicists. They expected that the expansion was actually slowing down due to the force of gravity. To explain the discovery, they theorized that there's a force speeding up the expansion of the universe. They called it dark energy. What if this hypothesized energy suddenly stopped pulling the universe apart? Let's assume the strength of dark energy diminished over time, but was still enough to counteract the force of gravity. What would that look like? If that were the case, the universe would become just like Albert Einstein imagined it 100 years ago, before Hubble's discovery changed the game, and Einstein's viewpoint. It would be static. The universe would neither be expanding nor contracting. Eventually, stars would exhaust all the gas needed for their formation. Fewer new stars would be born, and the existing ones would burn out. The universe would grow darker, packed with black holes. By that time, the Earth would be long gone, absorbed by a red giant star that used to be our sun. At some point, it would reach its eventual temperature minimum, absolute zero, or 0K. On the Celsius side, that's minus 273 degrees. At that temperature, atoms themselves would stop moving. The universe would become absolutely lifeless. But let's go back and assume that dark energy became so weak that it couldn't counteract the force of gravity anymore. Once the gravity took over, it would pull everything back. The universe would start contracting. Galaxies would draw closer together until they merge into one mega-galaxy. With the stars melding into each other, space would become hotter than the sun, and again packed with black holes, the result of exploding stars. These black holes would suck up everything around them: planets, stars, entire galaxies, even one another. Eventually, they'd form one monstrous black hole that would pull the entire universe into a single point, hot, small, and extremely dense. The universe would end in a big crunch, reverting back into what it looked like at the start. And who knows, the newly formed singularity might explode into another Big Bang, creating a brand new universe with new stars, new planets, and new life forms. We don't know exactly how our universe will end. We don't even understand what the dark energy pulling it apart is. That's why there's not just one theory explaining the ultimate fate of the universe. There are several good ones. Any one of them might be correct, but they could be wrong altogether.
Beetlejuice, Beetlejuice, Beetlejuice. Saying its name 3 times won't have the same effect as a certain bioexorcist, but it's still a sight to behold. At about 950 times bigger than our sun, Betelgeuse is one of the biggest stars in our universe. But that comes with a price. Just like us, stars have a life expectancy, and Betelgeuse is no different. It's a ticking time bomb that's ready to go, but we're not sure when. So, what if today was the day Betelgeuse went out with a bang? How would the Earth be affected? And would our universe ever be the same? This is What If, and here's what would happen if Betelgeuse exploded right now. Betelgeuse is one of the closest stars to Earth at a distance of only 650 light-years away. This makes Betelgeuse a fan favorite with professional and amateur astronomers alike. Betelgeuse is a red giant star, which means that when it reaches the end of its life, it will explode in a spectacular supernova, possibly even becoming a black hole in the process. Let's imagine that today is the day that Betelgeuse calls it quits and puts on one heck of a cosmic light show. But before getting good seats for Betelgeuse's grand finale, what sort of damage could an exploding star do to Earth? Well, think of stars as being like nuclear power plants. If they explode, you're looking at a disaster of cosmic proportions. Anything within 50 light-years of the exploding Betelgeuse will suffer massive shockwaves and be inundated with dust and radiation. Will you survive the celestial eruption? Actually, yeah. I know, it's weird, right? This is What If, so you're expecting everyone to die, but get this, everyone actually makes it out of this episode okay. The only side effect we're going to feel from Betelgeuse exploding is sadness. It's going to be a bummer when we say goodbye to the brightest star in the Orion constellation. Down here on Earth, we're going to see a very bright light in the sky. It could even be visible during the day, and bright enough to rival a full moon at night. Don't worry, it will be hard for you to miss, as this light show is expected to go on for quite some time. This is because Betelgeuse's light travels 650 light-years from its place in the universe to ours. The event will be breathtaking to behold, but Betelgeuse will be wrapping up its farewell tour. And that's it. It's been a pleasure, Betelgeuse. We're about 10 times too far away to feel any repercussions from the explosion. If we weren't, well, that would be another story. Okay, fine. We know what you want. This is What If, after all. Bring on the destruction. If we were too close to Betelgeuse when it explodes, our atmosphere and cells would be fried by the radiation and gamma waves. When you're exposed to high doses of radiation, it can burn and scar your skin, cause genetic mutations, and can ultimately be lethal. Gamma radiation, in particular, is incredibly powerful. It's pure energy. even more intense than light itself. If Betelgeuse were closer to Earth, it would be a literal and figurative lights out for all of us. Humans, animals, plants, you name it, we would all be toasted. An explosion that big from a star that immense would destroy life on Earth in seconds once the radiation hits us, even though the process of going supernova takes years. And even if we did have interplanetary ships to evacuate in time, Betelgeuse is so huge that there wouldn't be a planet in our solar system that's safe from the explosion. There, are you happy? Everyone dies. Thankfully, we're much too far from Betelgeuse to have any direct, observable, or harmful effects from the explosion. Betelgeuse is going to explode, but it will likely take another 100,000 years. When it does go, astronomers are going to have to rethink the structure of Orion. It may not leave a massive hole in the universe, but it will leave a hole in our hearts. Hey, who turned out the stars? Hello? Seriously, where did they go? Is this the end of the universe? Are we all about to get wiped out? This is What If, and here's what would happen if all the stars in the universe exploded at the same time. For every galaxy that's visible from Earth, there are 9 smaller ones that we can't see, even with all the technology we've developed. That's 90% of all space stuff in the observable universe that we're missing out on. We can't even see all the stars in the Milky Way. Our home galaxy is just too cluttered with gas, dust, smaller stars, and, well, one supermassive black hole. All that makes it impossible to tell how many stars there really are out there. But whatever that number is, it sure has a lot of zeros in it. Watching them explode all at once might mean that the Earth is about to become nothing more than dust in space. But there's also a scenario in which we could make it out alive. All stars eventually exhaust their nuclear fuel and die. Some of them depart modestly, first swelling to the stage of a red giant and then slowly cooling down over billions of years. More massive stars explode into a blinding burst of light known as a supernova. As stars go supernova, they spit out a superheated shockwave in all directions, along with a lot of radiation. Supernovas exploding 30 light years away from Earth could send us so much radiation that it would start ripping apart our ozone layer. Once the ozone layer was damaged enough to allow just 10% more UV rays to hit the planet's surface, nearly all marine life would be wiped out. With 2/3 of the ozone layer gone, people living in mid-latitude cities, from London to Melbourne, would start getting severe sunburns. Not even SPF 1000 would save your skin from that much radiation. Some stars would take it a step further. They'd collapse to form black holes. From Earth, this would appear as a lot of bright flashes in the sky. Because of the huge distances involved, the explosions would happen in slow motion. You could see one star exploding for over 10 years as the light from it continued to travel towards Earth. You wouldn't hear any explosions. Sound waves need molecules to travel through. Since space is a vacuum, there'd be no volume. Only a really cool light show. Would the Earth survive these cosmic fireworks? Technically, it's possible. Our planet's surface would be wiped out and all the oceans would boil away. Any survivors would be forced underground, watching out for further damage from exploding stars. But at least life on Earth could have a chance. Wait, am I forgetting something? Ah, right. We'd be sharing our neighborhood with one exploding star. If the sun were to go supernova, all life on Earth would definitely come to an end. The surface of our planet would become 15 times hotter than the surface of the sun right now. That alone would vaporize Earth within a few days. Lucky for us, the sun isn't massive enough to go supernova. But if it exploded, it would send matter in all directions, raining down on Earth 22 hours after the explosion. I'm not gonna lie to you, it would be all bad in the end. But then, exploding stars might form new stars and new planets orbiting them. it would be the beginning of a new universe. Possibly with new habitable worlds and new life forms.
This is the most powerful object in the universe. The biggest spinning magnet to ever exist. It's the cosmic equivalent of a great white shark. But it wouldn't eat you. It would just turn all your atoms to dust. This is What If, and here's what would happen if a magnetar entered our solar system.
If you thought neutron stars were big and scary, well, you haven't heard of their more powerful stellar cousins yet. Like neutron stars, magnetars are leftovers from supernova explosions. They're just packed with a lot more matter. Their density is so high that a single teaspoon of a magnetar could weigh in at 1 billion tons. They're also the most magnetic stars we know about. We use a unit called a Gauss to measure the strength of a magnetic field. Earth's magnetic field is only about 0.6 Gauss. The magnetic field of a magnetar can be as strong as 1 quadrillion Gauss. How long would it take a stellar monster like that to rip our planet apart? It wouldn't be the worst thing in the world if a magnetar was sitting quietly in our galactic neighborhood, but if it decided to stop minding its own business, there are 2 ways a magnetar could end all life on Earth, together with the planet itself. It could get too close to the planet. You'd start to feel its presence when it was about halfway between the Moon and the Earth. At that distance, a magnetar would erase the information off all your credit card's magnetic strips. Whatever you do, try not to get closer than 1,000 kilometers from a cosmic invader. Because if you did, your atoms would get stretched out of shape. Your bioelectric field would get scrambled, disintegrating your molecular structure. And your body would just disappear. Alternatively, a magnetar could destroy us from much, much further away. As if being the biggest spinning magnets in the universe isn't enough, magnetars can also be affected by something called starquakes. Starquakes happen when a star's crust cracks, letting massive amounts of radiation out into space. This blast of radiation could compress the Earth's magnetic field and partially ionize the Earth's atmosphere, even from 50,000 light years away. We know this because we've already come a little too close on at least one occasion. In 2004, gamma radiation from a magnetar reached our planet from outside our Milky Way galaxy. In just 1/5 of a second, it released more energy than our Sun has released over the last 250,000 years. Move that magnetar and its starquake up to 10,000 light years away, and things would get much worse. First, it would destroy our ozone layer. Then, it would wipe clean most of the planet's surface, along with all life as we know it. The truly scary part of this is that we wouldn't even know the magnetar was heading towards us. It would be a blink and you're gone scenario. I won't lie to you, there are magnetars close enough that if one had a violent starquake right now, we'd all get wiped out very fast. When scientists began their search for these interstellar monsters 40 years ago, they didn't realize how many of them exist out there. You might find some comfort in the fact that most magnetars don't make it much past their 10,000th birthday. Their short lifespan ends with them becoming neutron stars. Still dense and still magnetic, but not nearly as dangerous as a magnetar. What if all the stars disappeared tomorrow, together with all the planets, solar systems, and galaxies? What would be left of the universe if it suddenly collapsed? What could make it restart its cosmic cycle all over again? And how exactly could the entire universe break apart? This is What If, and here's what would happen if the universe ended tomorrow. Some 50 million years from now, the Martian moon Phobos will slam into Mars and shatter to pieces. In 100 million years, Earth will likely get hit by an asteroid, the size of the one that caused all the dinosaurs to go extinct.
In about 1.5 billion years, the sun will become so luminous that it will force the habitable zone to move outwards, leaving what's left of Earth to get crispy. Everything will eventually come to an end, even our almost 14 billion-year-old universe. What would it be like to witness the epic end of the cosmos? Don't get too comfy. The end of the universe would mean the end of everything in it. 2 trillion galaxies that we can observe from Earth, filled with a tremendous amount of everything, from enormous gas giants to weird-shaped asteroids. Everything would be gone, including you and whoever else is out there. But your last moments could be very different, depending on how the universe shut down. Here are 3 ways it might happen. One possibility is it might get really chilly. The universe is expanding. Galaxies are moving away from each other at an ever-increasing rate, despite the attempts of gravity to pull them back together. That's because a theoretical force called dark energy is opposing the force of gravity. If one day this dark energy pulled a little too hard, the pieces of raw material needed for star formation would become too far away from each other. All the existing stars would eventually run out of fuel, and there would be no new ones to replace them. It would get very dark and very cold. Once the temperature reached absolute zero, nothing would be able to move, not a single atom. The universe would become the most boring, static place, and would probably remain an endless void forever. I bet you were hoping for a more spectacular ending to this story. So let's add more action with the Big Rip. If the dark energy became so intense that it was able to nullify the force of gravity altogether, it would rip the universe apart. It would start with the galaxies, tearing them down one by one. Black holes would be the next to disintegrate, followed by stars, planets, asteroids. As the expansion of the universe ramped up, every form of matter would collapse on itself and decay into radiation. That, of course, includes you. The universe would end up full of single particles. Would it ever come together after its death? Let's try our luck with the Big Crunch theory. If the force of gravity fought back hard enough to overthrow the dark energy, the universe would stop expanding. It would shrink back instead. Planets would collide with other planets, the stars would slam into each other, galaxies would merge together. Earth wouldn't be able to dodge all the space matter for too long. The universe would compress into a very dense singularity, just the way it was before the Big Bang began spewing out galaxies. From that singularity, it could make a fresh cosmic start, with new planets, new stars, new life forms. This is What If, and here's what would happen if the sun exploded tomorrow. That star at the center of our solar system, that super hot ball of plasma that gives us heat and energy, and amazing complexions. Well, it's a ticking time bomb. The sun is 4.5 billion years old, but it's only expected to last about another 5 billion years. After that, the sun will expand, becoming a red giant. Then, it will shrink to become a white dwarf, a dying star, cooling for the next several billion years. Of course, we'll all be long gone before any of that happens, but still, can you imagine what it would be like to watch the sun blow up before your very eyes? With a name like supernova, you'd think that a solar explosion would be the most magnificent fireworks show the world has ever seen. But in reality, you likely wouldn't see anything. The sun is 150 million kilometers away from Earth, and it takes 8 minutes for light from the sun to reach us. And while that may seem super far away, in supernova terms, we don't stand a chance. For Earth to be completely safe from a supernova, we'd need to be at least 50 to 100 light years away. But the good news is that if the sun were to explode tomorrow,
the resulting shockwave wouldn't be strong enough to destroy the whole Earth. Only the side facing the sun would boil away instantly. The lucky other half would experience a rise in temperature that would be 15 times hotter than the sun's current surface temperature. And permanent darkness. And without the sun's mass keeping us in orbit, Earth would likely start floating off into space, while its remaining inhabitants desperately struggle to stay alive. There is a chance that our planet could lock into orbit around another star that might provide the same light and heat as our sun, but by the time that happened, we'd all be long gone. If we knew in advance the day that the sun would explode, then we could buy ourselves as many as 1,000 years of time, provided we had the resources to sustain ourselves for that long. And we could. Just a few meters below the ground you walk on, the Earth is maintaining a temperature of about 17 degrees. So if we had enough time to prepare, civilization could continue to live by moving underground into a huge network of fortified bunkers. Within a week after the explosion, the surface temperature on Earth would drop to minus 18 degrees. Within a year, temperatures would plummet to about minus 73 degrees. At this point, the oceans would begin to freeze from the top down. Within 1,000 years, Earth's atmosphere would freeze and collapse, leaving anything left on the surface exposed to cosmic radiation and meteor impacts. Hopefully, by that point, we'd have found ourselves a new home. The good news is that if the sun were to explode, and it will eventually happen, it wouldn't happen overnight. When the sun does die, it will be a long, slow, arduous process taking place over billions of years. The sun will get hotter and brighter, and it will start to expand. During this process, it will lose its outer layers to the cosmos, leading to the creation of other stars and planets, in the same way that the violent burst of the Big Bang created Earth. Who knows? Maybe new life could form. Can you imagine another Earth? A new humanoid species? It's hard to predict how our galaxy might look billions of years from now, and it's especially hard to imagine our solar system without the great golden anchor that keeps us all together. But one day, in the very, very distant future, the sun will expand, and then it will shrink, maybe leaving room for a new star to take its place. And if by some miracle humanity still exists at that point, where might we be living? Can you imagine your descendants being born on a space station?
What would happen if you took the most energetic light source in the universe and smashed it into a massive gravitational monster? Well, you might reverse the flow of time. How would this event unfold? How could it affect time as we know it? And what would happen if you got too close? This is What If, and here's what would happen if a gamma ray burst hit a black hole. Meet your first fighter, a black hole. Not so different than your average object with mass, except that it's extremely dense. Most black holes are the remnants of massive stars, and they have lots of gravity. The mass of this black hole is compressed to a point called a singularity. At this infinitely small point in the center, conceptions of space and time break down. Today's challenger is a gamma ray burst. Not so different from your average burst of visible light. Oh yeah, except way more energetic. Gamma ray bursts are the strongest and brightest explosions in the universe. In 1 second, gamma ray bursts emit as much energy as the sun will emit during its entire 10 billion year lifespan. So, if these two powerful phenomena collide, would space and time cease to exist?
There are a couple of things you should know before we get underway with our space-time obliterating cage match. The first is that our two contenders already interact pretty often. A black hole releases a burst of gamma-ray light when it's created. This burst spreads out evenly in all directions across the universe. So some of these gamma rays will certainly encounter another black hole or two. And these gamma ray bursts happen about once a day. They could flash for less than 2 seconds, or they could last for up to 30 seconds. The difference is whether the burst results from two neutron stars colliding to form a black hole, or whether it's the result of a star collapsing directly into a black hole without a supernova explosion. So, if you managed to observe these phenomena, would you witness a magnificent explosion about 1,000,000 trillion times brighter than the sun? Well, not quite. While some photons have just the right amount of frequency to be visible to your eyes, the frequency of gamma rays is way too high. Your eyes aren't advanced enough to see their beautiful bursts. But if you could see them, this insane amount of light would probably leave you blind. Now, surely this explosion must be loud, right? Well, once again, I come bearing bad news. It would technically sound like nothing. Yeah, sound doesn't travel in the vacuum of space. It needs a medium with particles to carry sound waves. But thanks to the scientists at NASA, a gamma ray burst would sound a little something like this. Okay, not exactly like this. These beautiful cello and piano notes translate the gamma ray frequencies into musical notes. Pretty mellow for such a massive explosion, right? But if you were close to this explosion, things would be anything but mellow for you. Gamma rays are hazardous. They can penetrate lead, concrete, and certainly whatever spacesuit you'd be wearing. As they passed through your body, they deliver an extremely high dosage of radiation. You'd suffer radiation sickness. You'd become nauseous, lose your hair, and even bleed. The energy could cause damage to your tissue and your DNA, leading to cancer or, worse, death. The gamma rays could cook you from the inside out. So you'd want to back up a little bit. Or better yet, reverse time. In 2018, researchers observing gamma ray burst pulses found that some events repeated themselves in reverse. That's right, it was as if they were moving backward. So, what does this mean for you? Did you just stumble on a way to travel back in time? Again, I have bad news. This is merely an optical phenomenon. Light has the fastest speed in the universe, but this is only true for the speed of light traveling through empty space. In other mediums, like water, it would be possible for electrons to travel faster. That means if gamma rays could travel faster than the speed of light, they would give the illusion of reversing time. So yeah, it's possible I oversold you a bit on the idea that if a gamma ray burst collided with a black hole, it would result in the brightest, loudest, time-destroying explosion of all time. But in some ways, it's all true. Now, until our sun collapses into a black hole and sends a burst of gamma rays in your direction, you don't have to worry. But if a black hole swallowed our sun, gamma rays wouldn't be your only problem. It's almost as old as the universe and as massive as 34 billion suns. It eats stars for breakfast. And now it's about to consume ours. Behold, the great and powerful black hole with the catchy name J2157. If it came close enough to our solar system, how fast would it destroy us? How would it all go sideways for our sun? And how exactly would this monstrous black hole end all life on Earth? This is What If, and here's what would happen if a black hole swallowed the sun. Black holes are scary enough. They form when big stars explode in a supernova and then collapse in on themselves. The most common black holes, the stellar ones, are only 16 kilometers in diameter, but they have the mass of a star at least 10 times more massive than our sun crammed in them. All that mass compressed into such a small diameter makes black holes extremely dense. If you came too close to a black hole's vicinity, beyond its event horizon, its extreme gravitational pull would turn you into a spaghetti noodle. But there are black holes so massive that they make stellar black holes look feather light. These are called supermassive black holes. These monstrosities lurk at the centers of galaxies and take up space roughly the size of our solar system. But most of them don't even get close to the size of black hole J2157. J2157 is the fastest growing black hole in the known universe, and it's the second largest one. Its event horizon has a radius of 670 astronomical units, which is comparable to the distance between the Sun and Neptune multiplied by 22. Whoa! If that's not scary enough, J2157 holds the title of the hungriest black hole we know. To stay in good shape, it gobbles up matter at a rate of about 1 sun per day. Now, take this monstrosity and bring it closer to our solar system. You can imagine how that would play out. If J2157 could replace the supermassive black hole that sits at the center of our Milky Way galaxy, to us on Earth, it would look 10 times brighter than the full moon. That's because of its incredibly large accretion disk, the matter the black hole collected on its way to us. And because it always needs to be the center of attention. This monstrous black hole would outshine most of the stars in the sky. If a black hole under 100 million masses of our Sun entered our solar system, it wouldn't swallow the Sun in one go. It would gradually start pulling matter from our star until all that's left of it would be a cloud of gas. In that case, you could expect lethal amounts of cosmic radiation headed toward the Earth. But that's not how J2157 likes to deal with things. A black hole of that size and mass would devour the Sun in a moment. But losing the Sun would be the least of our problems. Our planet could be torn apart by the tidal forces from the black hole consuming our Sun. Or it could be bombarded with an unthinkable amount of cosmic radiation. Or it would disappear into the black hole's event horizon, along with the rest of the solar system. Either way, you wouldn't get out of this alive. But no matter how big and scary J2157 is, remember that it sits at a safe distance of 12.5 billion light years away from us. I'd say we're pretty safe here. Now, if you ever plan to visit a black hole, you'll need to look into some survival tips. And we have a new show for you about just that. to help you survive whatever awaits you. "66 million years ago, an asteroid as big as Mount Everest was headed on a deadly collision course with Earth. The impact was so devastating that it wiped out the most gigantic, deadliest reptiles to ever roam our planet. But the dinosaurs didn't just die from one big boom. No, they faced a slow, agonizing end.